The procedures we're going to see demonstrated now cover most of the surface repair problems you're likely to encounter on single, double-sided, and some multi-layered boards. And keep in mind always the essential goal: non-destructive repair. Repair that seeks to equal or even surpass the quality and reliability of the original product.
We'll cover 4 basic tasks. Conductor repair, using both wire and flat conductor material. Repair of lifted or missing pads and damaged plated through holes. Repairing burned or missing sections of circuit board and delaminations. And the repair of edge connectors. The 2 basic considerations in all of these procedures are the need to avoid excessive heating and, as a first step, always clean and pre-tin the work well before starting. All contamination and loose foreign matter has to be removed at the outset, and the surfaces wiped clean with solvent. Naturally, when conformal coatings are present, they too must be completely removed from the repair area. So, we begin with the damaged conductors, and we may have a complete break in the run, nicks, scratches, and holes, or a portion that's lifted up from the base material. For small breaks, it's tempting to try and bridge the gap with solder, but in practice, this is difficult to do. The solder will ball up and not bridge the gap. It's not a recommended method. A better way is to use a wire jumper to re-establish the run, either surface-mounted or extended through the board's base material. Note the size of the wire. It's selected to have the same or slightly larger current capacity than the original conductor. A wire jumper is going to be installed to repair the damage on this board, and the first step is to cut away all the unbonded circuitry. All the burned material is now removed with an abrasive. If it was allowed to remain, it could act as a carbon-type resistance and cause further damage. After it's removed, the residue is brushed off and the area wiped with solvent. Next, both sides of the break are cleaned, at least 1/4 of an inch on each side, again using the abrasive followed by solvent. Since the wire jumper will be reflow soldered into place, the ends of the conductor are pre-tinned and cleaned. Liquid flux is then put on the joint area. The use of a wooden stick instead of a swab to apply the flux may be required to avoid the possibility of contamination from cotton fiber. The gap will be bridged with a piece of round bus wire. It too is cleaned, and then to keep it from rolling on the board, it's slightly flattened with pliers. Now it's cut to a length that is at least 1/4 of an inch longer than the break. The wire is positioned along the run with tweezers and then soldered in place. A lap flow tool could also be used here instead of the iron. After the joint cools, all flux residue is removed with solvent, and then the joint is inspected to ensure it meets the established standards. This is a good one, showing at least 1/8 of an inch overlap on each side. Here are the recommended specifications for this type of repair. Now we'll see a through board jumper or wire staple installed on this board, which has already been cleaned. Since the wire is mechanically anchored on both ends, Through-board jumpers provide the most secure type of jumper repair. The wire in this case is already pre-tinned. It's cut and bent to the proper dimensions to bridge the gap. 2 holes will be required, going through both the conductor and the board. As an aid in locating them, a centering spot is made with an awl. Drilling is done with a tiny ball mill that makes holes about 5/1000ths of an inch larger than the wire. The staple is then inserted from the opposite side of the board and pushed in tightly against the board surface. On the opposite side, the leads are bent over and then cut to the proper length. The ends need to extend over the run by at least 1/16 of an inch. In place of the cutters, a plastic soldering aid is used to push the ends flat onto the conductor. A good cleaning with solvent and brush comes next. And now the soldering will be done by the normal technique for hand soldering axial leads. Here's what the repaired area looks like after it's cleaned up. Here are the recommended specifications for this type of repair.
Wire jumpers, when they're the right size and put in properly, are quite acceptable in many cases. But they require drilling more holes in the board, and if you're dealing with a multi-layer board, that can be a real problem. The preferred method for replacing a portion of conductor is to use flat material that's as close as possible in dimension and appearance to the existing circuit conductor. Replacement material can be obtained by cutting a piece of copper sheet, removing a section of similar sized conductor from a scrap board, or, as we'll see now, using one of the commercially available frames of pre-tinned track material like these.
First, all the damaged conductor is cut away with a sharp knife, and carefully, so as not to damage the underlying board. The area now gets cleaned with solvent and wiped dry. Then the frame of replacement tracks is lined up with the run so that the correct width of new material can be selected. The selected track gets a good cleaning with the abrasive stick, and it's done on both sides to remove all the surface oxides. It's cut to a length that will allow at least a 1/8 inch overlap on each end. The joint will be reflow soldered, so the existing conductor ends are pre-tinned and fluxed and then the replacement piece aligned and soldered into place. The lap flow tool being used here permits a one-handed soldering operation by holding the new piece in place during and after heating. When cleaned, the completed repair is very close to the appearance of an original run. The recommended specifications for this type of repair are shown here, and some specifications will further require that the new track be bonded to the board with epoxy or other material. The recommended method is known as overbonding, as shown here. It can produce a bond as strong as the original one and has the further advantage of creating a heat sink that can reduce the possibility of any reflow at the lap joints when heat is applied to some other point on the conductor. Also, since the bonding material is applied after the soldering process, the chance of contaminating the solder joint with bonding material is avoided. A second method of bonding is known as underbonding and is used where the primary requirement is appearance or where overbonding is not practical. Such is the case with connector fingers that need rebonding to the board. The surface of the finger is a contact area that must not be covered.
Lifted, missing, or damaged pads are perhaps the most common type of damage encountered in repair work. When they exist on a double-sided board with plated-through holes, they're best repaired by drilling out the holes and then eyeletting a new pad, or pad and track replacement, into position. A commercially available pad and track repair system like this can permit you to do a reliable repair job by hand setting either eyelets or funnelets. It contains all the materials you'll need. Let's see how they're used, and we'll take the lifted pad situation first.
On this board, the pad itself is not damaged, so the first step is to flatten it back down and put a piece of pressure-sensitive tape over it to temporarily hold it down while the through hole is enlarged to receive the eyelet. Instead of the ball mill, you could use a drill bit if necessary. The area will get cleaned with solvent after the tape is removed. A funnelet of the proper size is selected and is inserted through the pad and the hole in the board. And then setting is done using the precision tools, the support tool underneath, and the setting tool with its guide on top. Downward pressure sets the funnelet in place. Solder is applied carefully, working it around underneath the flange of the funnelet. Then the same joint is made on the other side of the board. If any solder flows into the funnelet, it can be removed with a solder extractor. After cleaning, the repaired hole is ready to receive a component lead. Here we have a situation where both pad and track need replacing. So after cleaning away the damaged area, the hole is enlarged for the eyelet. The conductor end pre-tinned and the area cleaned. A pre-tinned replacement track pad of the correct size is selected, cleaned on both sides, and then cut so that there will be an overlap of about 1/8 of an inch. Again, the joint is pre-fluxed, and then the eyelet and track pad inserted and carefully aligned. After setting the eyelet, the two joints are then soldered. A lap flow tool would be more convenient here, since you wouldn't need to hold the work with another tool. After the cleaning, the finished joint should look like this. Here are the recommended specifications for this type of repair. For fused eyeletting, portable units are available and can produce factory-quality results under field conditions. Essentially, they provide a form of resistant soldering with controllable heat, pressure, and tinning. The steps in the repair procedure are the same, except instead of hand setting the eyelets, the work is clamped in here. It's first cold set to check pressure and alignment, then a heavy surge of controlled current is sent through for a preset time to fuse the joint.
The advantage over hand setting and soldering is that you eliminate any outgassing problems and get a uniformly tight swage and fusing of the eyelet. Sometimes you may have to do the opposite of all this. Remove an eyelet, rivet, or terminal.
Here's a turret terminal that has to come out, and to do a clean job of it without tearing up the board, a ball mill is used. The size selected is just a bit larger than the hole size. What you want to do is to just thin the flange without going through the hole. Then you can pull the terminal out, leaving the hole undamaged and ready to receive a replacement.
Now let's take a look at a board that has a badly damaged area. It's not only burned with lifted circuitry, but the base material itself has been destroyed. The repair process is a two-stage one. You have to first rebuild the base material and then re-establish the circuitry.
All the charred material is first removed with the ball mill. The hole through the board is enlarged, and its edges beveled to provide additional surface area for epoxy. To back the hole, a piece of Teflon is used and held in place by tape. Now a mixture of powdered fiberglass and epoxy is made. For the fiberglass, you can use ground-up circuit boards, and for the epoxy, select a type that cures at a low oven temperature. You want to put enough of it on so that it comes a little above the surface. After an air cure, the tape is removed, and the board goes into an oven to complete the curing process. A low temperature is used to avoid damaging any of the components. The base repair is now completed by grinding the area flat and drilling a hole for the replacement track pad.
You can repair holes up to about a ½ inch in diameter this way. But if you get one much bigger, the best approach is to cut a plug of the right size, thickness, and shape and epoxy it in place.
The damage on this board was extensive and required cutting away a large area. The edges of the hole were then beveled to accept a plug. A piece of scrap board stock is used, and the outline of the hole is carefully scribed. The pencil is angled to get the exact size. And then the plug is cut out using a fine jeweler-type saw and following the line very carefully. Next, the edge of the plug is beveled to get it as near perfect as possible. And then both board and plug get a good solvent cleaning. After mixing the epoxy, it's put on the inside of the hole, taking care to cover the beveled edge all the way around. Note the Teflon backing block that's in place underneath. After the plug gets positioned, another block will go on top, and then the blocks will be clamped together until the epoxy cures. Later, after the epoxy has hardened, the blocks are removed. And the abrasive used to grind off the excess before re-establishing the circuitry. Here are the recommended specifications for this type of repair.
Delaminations, sometimes called blisters, are separations between the layers of a multi-layer board. You can see two of them here. Sometimes they occur during the wave soldering process due to poor quality of the lamination itself. On this one, the affected area is accessible and does not include any circuitry, so we can relaminate it with some epoxy.
The board has been cleaned and baked dry. Two small holes are drilled at opposite ends of the delaminated area. A small syringe is used to inject epoxy of the proper type and viscosity. The needle of the syringe has been replaced with a short length of plastic tubing, and the epoxy is injected until it fills up the void, and the excess bleeds through the other hole and forms a small bead on the top surface. A vacuum chamber can aid in totally filling the voids. The board now goes under a heat lamp for about an hour until the epoxy's cured. Then the bead will be ground off with a rotary abrasive. Here are the recommended specifications for this type of repair.
Circuit boards very seldom wear out. They may blow out, but in normal use there's very little wear and tear on them. One exception is often the fingers on edge connectors, and the problem is either a lifted finger that's still serviceable, worn fingers that have lost their contact surface and need to be replated, or fingers that have broken off altogether and need to be replaced. Worn edge connectors are covered in the next section under edge connector replating. Now we'll see how the other repairs are made.
This lifted finger is going to be rebonded using an anaerobic adhesive, so it gets a solvent cleaning first, and then the activator is put on and allowed to dry. This is followed by the adhesive. Again, the non-adhering Teflon blocks are used to clamp the joint, but not so tight as to squeeze out all the adhesive. Here's how the repair looks after it's been cleaned up. Repairing this connector is going to involve finger replacement, as well as bonding to the board. So again, the first steps are to remove any damaged or lifted portion of the conductor. And then give the area a good cleaning with an abrasive, followed by solvent. Replacing the conductor is done first. One of the proper width can be selected from an available frame of straight replacement tracks, cleaned and cut to size. Alternately, a piece of copper foil of the same thickness can also be used. Next, the overlap area is pre-tinned. The reason this is done first is that the adhesive used later may not withstand the high temperature. After the joint is fluxed, the new finger is temporarily held in position with a piece of tape. Then it's reflow soldered into place. The replacement finger will now be bonded to the board, using the same two-part adhesive system we saw earlier with the lifted finger repair. After it's dry, the clamp is removed and the finger trimmed to the correct length. For the final step, a file is used to slightly chamfer the edge, being careful to abrade away from the conductor end. Properly performed, the repair is virtually indistinguishable from the original appearance. Here are the recommended specifications for this type of repair.
On many boards, you'll be dealing with edge connector fingers which have been gold-plated. So to complete the repair and bring the board back to its original state, you will have to do a replating job.
You'll find a full presentation of what we've covered in your handbook, so we'll stop now. Your instructor will want to review the material with you, and in the notes section of the handbook, have you write in the particular specifications, standards, and practices of your organization. Then we'll move to our next lesson, replating edge connectors.